job. Hello, beautiful nerds. My name is Monty Paulson. I lead the Passive House team at RDH Building Science, and it is my privilege to welcome you to the Global Passive House Happy Hour, hosted by Passive House Accelerator. This is an inclusive gathering. We welcome people from all Passive House communities. We welcome people working on electrification, embodied carbon, climate adaptation, indoor air quality, and that little task of retrofitting 6 billion buildings in our lifetimes. So please turn on your cameras. We'd like to see you. Please turn on your microphones. We want to make some noise together in a moment. And let's give a cheer tonight to the Government of Canada, which has announced $170 a ton carbon tax over the next decade. To $170 a ton.
Cheers, Canada.
Canada.
Canada leadership.
It's like, really?
That was a great, what?
The cold does bring something.
It's true. I have no doubt that the new administration will be matching it within weeks. So now let's mute your mics, close that other app you've got open. We have an amazing show tonight, including a presentation by Gesa Zellermann and Scott Kennedy from Cornerstone Architecture. Over to you, Prudence. Is she here?
Prudence is not here, I don't think, because she is having to run up to Boston before the storm. And so we're going to be showing this really cool video about the Witsit project. And I wonder, Scott, since Prudence is not here, if you would be willing to say a few words to introduce the video. We watched it last night, but I think it'd be great for people to hear from you about it.
So this is a video about a project that we're working on up for the Wet'suwet'en First Nation. It's a passive house. It's got some interesting limitations because we're trying to build a 26-suite building and we only have 600 amps of single-phase power. And so passive house is the perfect way to build an all-electric building up north and keep that power within what we're trying to do. It's got an interesting dimension to it in that we've gotten a grant from Forestry Innovation to have Passive House Canada train up to 40 of the local residents in how to build a passive house. So we're trying to get the Passive House trades training course to them through Passive House Canada. We've got a little COVID problem with how we're going to actually do the in-person part, but the plan is that they will build the wall panels from local supplies as much as possible and local labor as much as possible for the building, and we'll put them up pre-built. And Louise, who's on the call, is going to be organizing the call or the course. And of course, Sean has volunteered to go up as well to help us out do this thing. So it's really a community-based training piece to create a passive house for the community. And so we put this video together. Literally, it's hot off the press from yesterday to actually help the community understand what we're going to build for them because they have to vote the land for it.
Witsit
the music is by the local
band. Located on Seaton Road. It is intended to address the affordable housing shortage within the Wet'suwet'en First Nation. The project will provide 16 studio and 10 two-bedroom apartments. 3 of the ground floor suites will be set up to accommodate persons with disabilities. Other facilities include a common room with a kitchen to allow for life skills training, a counseling room, a boardroom, a laundry area, a recycling room, and a building management office. The exterior of the building will be finished with cementitious panel siding and standing seam metal roofing to minimize maintenance costs. There are sunshades on the south, east, and west exposures to control overheating on hot summer days, and the sunshades will provide interest and color to the facades. The surrounding grounds will be outfitted with a covered outdoor lounge area, a fire pit for social gatherings and patio areas. There will be parking for 8 vehicles and a covered parking area with electric outlets to accommodate 8 bikes. The entry area will be constructed using log timbers and feature locally created art. Studio suites have an entry area and closet flanked by a bathroom outfitted with a shower. There's a galley kitchen with 24-inch appliances leading to a living space which can accommodate a bed and a sitting area. Off this room there's a second closet and a storage room designed to accommodate a small chest freezer. Two-bedroom suites have an entry flanked by a bathroom outfitted with a tub shower. There's a galley kitchen featuring 24-inch appliances leading into a dining room and a living room. 2 bedrooms and a storage room designed to accommodate a small chest freezer open off the main living area. The project will be built with attention to both its impact on the environment and its future operating costs. To reduce heating energy, the walls will be 24 inches thick and filled with blown cellulose insulation. Cellulose insulation is preferred, as it is derived from wood fiber, a renewable carbon sequestering resource. Windows will be triple glazed in triple sealed, multi-point locking window frames, and the building will sit on 12 inches of expanded polystyrene insulation to insulate it from cold winter ground temperatures. To ensure against drafts and cold spots, great attention will be paid to connection details to ensure that they are airtight and free of thermal bridges. To maintain air quality in the building, an enthalpy recovery ventilation system will be installed to provide 24-hour continuous fresh air to every bedroom and living room. The system will extract air from bathrooms and kitchen areas and recover 80% of the heat and moisture energy from it, and transfer it to the incoming cold fresh air as it is exhausted. There is no recycling of air between suites. The air will be tempered to provide some cooling in the summer, and a portion of the heating energy required in the winter with cold weather suitable heat pumps feeding coils in the fresh air system. There are 2 central ventilation systems, one serving units with a north exposure and one for the south exposure, as each system can then adjust to solar conditions. Hot water will be created using carbon dioxide-based heating pumps. They produce 2 to 3 watts of energy of heat for every watt of electricity. BC Housing and the development team look forward to delivering this project to the Witsec community.
Fantastic. Thank you, Scott. That's very cool. So we're going to jump into breakout rooms. So these are going to be 5-minute sessions, and that goes by fast. So please do some rapid fire introductions to one another. Make sure you get around the circle or the squares, I guess. And we'll see you in 5 minutes. Thanks, everybody. I hope that those small groups are fun. I am going to make some announcements, and then we'll get moving. I want to start by saying that I just shared in chat right above Peter's message. There's a Google Drive link, and that is for the slides that you're about to witness from Scott and Gesa. This is the most fast-paced presentation we've had on record at the happy hour. It is fantastic, and there's a lot to absorb. So you can relax and just absorb it and know that you have the actual slides at your disposal. So please go ahead and download those slides and tell me in chat if my link doesn't work. I'm always paranoid about that.
It works, but 123 megs is a lot.
Yeah, it is a big file. It's a big file. Okay, here we go. That's what I want. Every week on the Passive House Accelerator website, we publish a Passive House Weekend Preview with information about what's coming up in the Passive House world. So you can go to that to get details. We've had a packed week, and you're here, of course, for this presentation. The Passive House podcast, the episode this week is with Julie Torres Moskovitz, and it's a great conversation. She's a practitioner and educator in New York City, and the conversation ranges from her pathway to Passive House and social equity and engagement of youth and all sorts of great stuff. We've got some really great socials, of course, every week around Passive House and high performance building. And the BS and Beer Show, I want to highlight, that's going to be tomorrow. That is with Lloyd Alter as guest on the show, and he has a critique of a book here that it sounds like will be very entertaining. So you should check that out. And then Building Science Fridays, the special guest is Maureen Sanchez of RDH Building Science, who most of us know and admire quite well. And then lots of educational resources here to access as well. So with that, I'm done with announcements. I think it's time for Monty to make some introductions.
Awesome. Well, the one thing I want to say about Scott Kennedy and his colleagues at Cornerstone Architecture is that Passive House is a team sport. Well, let me tell you how I met Scott. There was a time here in Vancouver, not all that long ago, when Passive House was virtually unheard of. Oddly enough, we were still having conflicts within the green building community. We were fighting between CAGBC, USGBC, Cascadia GBC, the Living Building Challenge, or what was about to become a Living Building Challenge. And Passive House was like the weird new kid. And so to try to get around having to fight about standards, some of us were doing an event series called Thick Walls Are Sexy. Full credit for that name goes to Bryn Davidson at Lane Fab. We should have on here some night. So one of our thick wall or sexy events where we were just trying to talk about great buildings and not worry about the politics behind them. I presented on some of the early Passive House projects we're working in Vancouver. And the next day I get a call from Scott Kennedy, who says, oh, you probably saw me at the event. I was standing in the back and I'm usually the tallest guy in the room, which was true. Scott and his firm grabbed a hold of Passive House full hog in no time. He trained most of his staff to do Passive House. They started converting how they were doing, and they converted a project that was already on their boards into Passive House. And what Scott has illustrated both with his own company and with the folks he works with is this wonderful team approach to Passive House. And I really want to call out Gesa, who actually had a child during this project, Gwill, and especially Ed Kolick of 8th Avenue Development and Doug Wilson of Peak Construction, without whom this amazing project would never happen. So it's my real honor to introduce Scott, who's been such a great team player. He's gone on to become head of Passive House Canada, chair of Passive House Canada board for a couple of years, and end the year with this fantastic project.
So yeah, like Zach said, we have a lot of slides and not a lot of time, so we're gonna fly through it, but then we have some time afterwards for answering questions and to chat. So we'll be presenting the Heights. It's 85 suite mixed use 6-story project here in Vancouver at 388 Skeena Street. It was our very first completed Passive House project, and we really have to thank 8th Avenue Development and Peak Construction for going that step with us, going passive and reaching past the minimum code requirements. We are also currently working on another Passive House project with 8th Avenue, and this project was built under the city's Rental 100 policy that allows higher density for projects as an incentive to provide much needed rental housing. The project was completed in February 2018, and it was a pretty big deal. The mayor came to the opening ceremony. At the same time as the Heights, we were working on Spire Landing. It's a 95-unit Passive House project designed to the same principles, was spearheaded by Simon Richards from our office, also falls under the Rental 100 policy and was built by Spire Developments. Outline of the project. So I will quickly walk through the first points and then Scott will talk about monitoring and actual energy performance. The Heights only was recently certified as Passive House Classic by Passive House Academy. These are the stats. The frequency of overheating based on the PHPPH is shown here at 0%, which unfortunately is not true. And probably the issue of overheating is one of the biggest lessons learned for us on this one. The basic building envelope is probably more effective than required. And this is because we were chasing primary energy the whole time. Trying to keep this one under 120 was our biggest challenge. We probably would have looked at lower solar heating glazing, for example, if this would have not been the main issue. This is a typical section showing the elevator and exiting structures, extending the thermal envelope into the parkade. And then this is a design pH image of the same problem, the ground floor connection to the parkade, plus code requirements such as auto openers and closure ratings made this area quite tricky in terms of thermal bridge free design. These are some interior shots. The project is very dense. 72% of the units are 1-bedroom and studio apartments. And when we look at the annual heating energy balance graph from the PHPP, you can see that the internal heat gains are huge, which is probably because of the density of the project. And it was interesting for us to see that the thermal bridges didn't have a big impact at all on the project. So really the comfort and health became more important than the energy performance. And retrospectively, the thermal bridges of the parkade probably were not the biggest concern. Envelope details. We looked at different approaches, exterior insulation with Roxol and EPS, and the interior insulated version. We then went with the interior insulated wall. Is fairly conventionally framed with conventional siding installation, which helped us with detailing. And the area could be finished up inside in dry conditions. There were some sequencing issues. Peak built full-scale mock-ups of the walls, which we had them in the office first, then we hauled them to site, and they were hugely important and became a good reference point for everyone. We did a woofy analysis of the wall. You can see some movement, but all within the range. Then for the sequencing of the wall, first we framed the exterior 2x6 wall. We put the air barrier on top, built the floor, wrapped the air barrier around the floor and joist. Then we framed the next level on top of the overlap, put the moisture barrier on, in this case, the Siga My Vest. And then we installed so we insulated the exterior wall with bat. We installed the quick therm, which is 2 inches with the EPS, with a polymer face that became our air barrier, taped the My Vest to it, taped the window frames to it, installed the interior service cavity wall, insulated that with bat as well. So this is this same thing in progress. You can see the moisture barrier and the air barrier wrapped around the floor ends. Then here is the taped air barrier. The trades took great care in fixing all the little nicks that happened, but the product was actually tested with some polymer missing and it still performed fine. The Euroline Thermoplast was the only locally made Passive House certified window at that time. So we used this one and we added some low solar heat gain glazing on the west facade. We opted for the install on the outside face, which is conventional for trades here and in line with the outboard moisture barrier. When you look at the therm model, the install is not ideal. The isomers are quite bent, but Vancouver is quite mild, but very wet. So this install was worth the energy use penalty for us. This is a corner unit facing southwest. You can barely see the low solar heat gain coating on the glass. But this is another thing that Passive House became great for us because it's located at a very busy street, so noise is not an issue with an envelope like this. This is the commercial space. We use the same windows for the glazing here, installed between wooden posts, EPS on the slab, extending 4 feet up, columns and walls to deal with thermal bridges here. This is the same section highlighting thermal bridges, mostly related to concrete. To ensure continuous air barrier, we kept the inside walls off the exterior walls so we can install the air barrier continuously and have easy access for taping and sealing. This is the floor junction where you can see in the detail the air barrier wrapped around the joist ends and the therm performs quite well. This is the slab edge junction. We notched the slab so we can install the guardrails on that level thermally broken, and we had some extra insulation on the outside of that slab edge there. This is a cold concrete slab at a planter where we shifted the planter wall outside to add extra EPS and insulation on top of the slab. We were looking at isocorps, but then opted for insulation on top and bottom instead. This is a balcony deck transition with extra insulation on top. We installed sunshades on the south side of the building, fastened to the rim joist. Probably could have chosen a bit more dense profile. And then we have here on the left, steel canopy installed with the wood as thermal breaker. In the middle is the elevator shaft at the elevator lobby floor, where we kept a gap and insulated that to try and keep that connection as minimal as possible. And on the right side, you see the commercial area with the EPS on top of the concrete, but we did forget about the formwork that then got embedded in the EPS and became thermal bridges. Air tightness testing, we achieved 0.29 air changes per hour, which was very exciting. Probably the biggest issue were the parquet doors, which had to be rated, and we couldn't source good doors, so we just ended up using standard parquet doors. Building systems, elevator, we used the Kony EcoSpace, efficient motors, low standby energy consumption. We insulated the inside of the elevator shaft with rock wool, and we kept all components thermally broken with 4 inches of wood blocking. For ventilation, we looked at 4 different ideas, but then went with a semi-central system. We used 19 Zehnder Comfort Air 550s, located them on level 6, and then each of those HRVs vertically serves a stack of up to 5 suites with fire dampers on each floor lane. This allowed us to keep the runs to the exterior quite short. and easy access for building management to access the HRVs for maintenance, exchanging filters, etc., without the residents having to access anything. That was earlier fire damper and HRV. This is now the in-suite air distribution for hot water. We used gas. There was just not much else there at that time. For newer projects, we are using the sand and CO2 based heat pumps that are much more efficient. Plumbing vents can cause significant losses. We overlooked that in the beginning, so we ended up wrapping them with insulation in a panic in the end. For appliances, we are using efficient appliances such as heat pump type dryers and recirculating hood fans, which took a little bit of convincing with the municipalities, but then were approved in the end. And now Scott and the monitoring.
Everybody hear me fine, I assume? So what we did is we did do some monitoring of the building. We had various monitors put in it. We were fortunate to get a little bit of, not enough data, but enough to at least help us understand what was going on. So we looked at the indoor humidity in the building, and it seemed to be very well kept. The gray line is the outdoor temperatures in Vancouver, outdoor humidity in Vancouver, and the other lines are individual suites, north, south, and west, typically suites, and it seemed to be very good that way. We also looked at indoor CO2. The red line represents 1,000 parts per million. And you see generally the suites are really kept in a zone between 500 and 700 quite well. And we get the odd occasional one, but that's a party or something going on, I assume. We looked at, because we had the sheathing on the outside of the building, and Vancouver has this tradition of leaky condo problems based on too much moisture on the sheathing line. We did monitor the moisture on the sheathing line, and we did find that it's, it stayed well within the parameters. It just briefly went out of the parameters every once in a while, but nothing that we were concerned about at the time. We did a split insulation on the roof. So we have some of the insulation above and some of the insulation in the cavity in order to take advantage of the cavity. And we again measured the moisture content on the plywood at that interface, which was not what you would think is ideal under the building code, but we did some WUPI analysis and felt it would perform well, and the monitoring proves that it does. You got to remember that a roof is open to the north, or the winter, cold sky, which is much colder, but it seemed to be performing quite well. We also monitored a bit of shrinkage in the building because it's a 6-story building. It's fairly early parts of the time doing these things, and we looked at the shrinkage. We did find that the exterior walls didn't shrink as much as the interior walls. So we saw a little bit of shortening on those interior walls relative to the exterior walls. This is really the issue that we face with this building, is that it is a hot building. It tends to be much warmer than we thought. We believe, as we go through it, we think it's mostly to do with internal heat gains are much higher than what is assumed in a PHPP. And we're going to talk about that a little bit. But we did have, this is a July month, so it did get quite hot and occasionally went up as we go. And sometimes even in the winter, it tended to overheat. And this was kind of a tally of the suites that we monitored and how often they were overheating in terms of, we're supposed to be 10%. So one suite on the north met it, but even some of the north suites were overheating. So that can't be solar heat gains. That has to be internal heat gains. So that's something that we learned on this building, and something that we felt is something important lesson to take forward in what we do from now on in. In July, we found that, again, some of the suites were quite badly overheating, even the north. So you can see that that is an issue that we're trying to deal with in the building. And we were on a busy street, so we wanted to see just how often we were going to have to change the filters. And so something in the order of 3 months, these filters got pretty dirty. So we had to come up with a slightly more rigorous changing of filters on the building. We find that even oftentimes in colder days, there are a lot of windows open in the building on the south face. And that's all part of the operation of the building that we have to think a little bit about as we move through working these buildings. And the other piece is we really hadn't even been talking about climate change at the time we did this. And we realized that a lot of the data, the climate data that we use, is actually old data. It's not new data. And I know there's been lots of discussion, and I know there are tools coming in the PHPP to help us rethink some of those things for this, particularly this overheating event that we need to think about. So these are a few of the conclusions: that overheating was an issue, CO2 seemed to be fine, relative humidity seemed to be fine. And the way this HRV system works, it's interesting. It's each of those 5 suites is on one HRV, but the suites all have a button in the kitchen and a button in the bathroom, where if you put it, the HRV will speed up for all 5 suites for about 20 minutes. And that seems to have been a very good strategy. And it seems to have worked quite well in this building. And it's one that we're contemplating doing on a very small project that we're working on right now. So now let's look at the energy performance of the building. So I managed to get from our utility power company the actual energy consumption of the whole building. And now this includes the parkade. So it's not a PHPP related energy, but this includes the parkade, and this is kind of the profile of the energy use in the building. And you'll see that it's actually fairly flat, and you don't get all that big a peak in the winter months. And that's telling you that we have a passive house and it's working wonderfully. So this is the heating estimate of where the energy is going in the building as it is. You can see that the gas consumption, which is solely the hot water in the building, is a very big chunk of the energy. But what was really surprising to us was that the electrical energy between the common areas and what was actually in the suites was about 50-50. And we really felt that the common area electricity seems to be much higher than we would have expected. Part of that is because we're not using much energy for heat in the suites. And part of that is, I think, we need to also be looking at these parkades and these other facilities in the building that are outside the PHPP when we think about energy consumption in these. And so that's something that we're going to try to refine as we move forward, but we're happy to do passive house buildings. One thing I did do is I looked at, if we replace the gas heating with the Sandons, what would happen to that equation? And you can see that by using a Sandon heat pump or any kind of a heat pump, that hot water generation becomes a much, much smaller portion of the total energy consumption of the building. Excuse me. So this is what we estimate the heating energy for the building to have been. And you can see that it's very, very close to the PHPP. That being said, we have some internal heat gains that are obviously aiding that, but I also think we have some opening windows even in the winter that are probably penalizing that. So I think that, that we know that passive house works. There's clear proof that it's really a great way to go in a cold climate like we have here, a heating dominated climate. So the other piece that we were looking at was the plug loads that were actually going on in the suites. And I was able to extract these because I had the total energy consumption for the building, and I had the bills from the owner of the building for what he was paying for the common area meters. And when I subtracted the two, this is what I got. So the PHPP was telling me, we would use about around 100,000 kilowatt hours, and we ended up using closer to 230,000 kilowatt hours. That is something that I think is significant. That is going to turn into internal heat gains in the building. And I think we need to be analyzing these buildings for that as we move through thinking about these things. Now we have another building, which is a certified passive house up in it's up in Smithers, which is about 20 minutes from where we're doing that with Wet'suwet'en building. And if you saw Monty's picture when we did that air tightness envelope, that was Monty sitting in this building doing the air tightness test. What we did find out, because we were able to get data of individual suite meters on that, is these are all pretty much the same suite. And you can see how much different there is from one studio to the next. One's using 135, one's using 36, one's using 17, one's using 45. It's amazing how much variation there is that's really related to occupant behavior. And again, that's going to affect what's going on inside your building. And my friend Lynn, who's on the call here today, has always talked about when people live in a passive house or a building that's supposedly a green building, they kind of maybe get a little laissez-faire and think, well, the building's doing it for me. My behavior doesn't have to help. And maybe that's not true when we think about lights and other such energy. And that's just something that's a reality, and we got to think about these things as we design buildings. So this was something, again, that we looked at in the building was the actual gas consumption. Now this is related to hot water use primarily. And this is kind of what we ended up with in the PHBP versus what we actually found in the building. And again, when you're putting this much extra hot water in the building, you're going to contribute to overheating of the building. So this is something that we worked out a little bit. We don't actually, unfortunately, we don't measure actual how much hot water is flowing in the building. So I relied on an engineer who came up with a little formula. He said, well, it's probably around 50 liters per person per day, which quite honestly is about double what is modeled in a PHBP. Now we don't have full data on that, and we're hoping to build a building that we will get better data on that sometime in the future here. Well, actually it's coming up pretty quick. So the one thing I did look at was, hey, if we change the gas hot water heaters to our heat pump hot water heaters, what would happen to the kilowatt hours per square meter per year, which is part of the passive house. So you can see it's a major difference when you convert to something that's about 3.5 times as efficient from something that's probably running about 90% efficient. And so this is an important thing as we move on to electrifying our buildings. That being said, if we did convert it to fan and heat pumps or something similar, it would still cost our developer a couple $1,000s a month more to operate. And thus the $170 carbon tax, which would level that playing field out for sure. So that's something that I think is going to be very useful as we work through. So here in BC, we have a thing called the STEP code. And the STEP code has an ultimate total energy use intensity of 100 kilowatt hours per square meter per year in our highest step. So I, again, looked at the building and I said, well, as it's performing right now, it's about 117. But if we change the heat pump hot water, it would be 87. But if we add cooling back in, it's going to be a little bit higher. So I think these are important things we have to think about. I know there are other savings in this building, which we're bringing into some of our other buildings, particularly in the parkade part. But this is a tough target to meet. TEU of 100 is going to be very hard to hit. So this is a building literally a block away that we're tendering. I think the drawings go out tomorrow for tender. But at any rate, this building, we have a bit of a grant to do some monitoring in. We're going to be working with RDH and with Integral to actually get some better data on the building. And we took a few lessons. So one of the things we've done on this building is we actually are going to be putting operable blinds on the south face of this building so that we can cut those solar heat gains down quite considerably. And we're still playing around with what actual coating on the window we're going to use is in conjunction with that. Second thing is we're putting a central ventilation system in. We're using 2 large units in this building, one for the north, one for the south, and we're putting a central cooling coil, it's cooling and heating coil on those units using heat pump technology, which will really help mostly in the summer in terms of trying to keep those temperatures down if those internal heat gains are as high as what we think. The third thing we're doing, we're going to a Colmac heat pump on this one, and our engineers are actually using the Colmacs. They have fans in them, and they're actually going to use the fans that run these Colmac heat pumps to actually also provide the ventilation in the parkade. So the idea is to share the energy of the fans to do 2 jobs, to ventilate the parkade and to generate the hot water for the building. And so this last slide are all the passive house projects we're working on right now, or are a couple of them are built, or a couple of them under construction. And I know we have 5 or 6 more coming, and we're very happy to share this with you. Thank you very much.
Wow. Did everyone get that? 95 slides, I think it was. And it's funny, Gesa, it took you like 10 minutes for you to get a glass of water. I was waiting. I'm like, her mouth must be just dry like no tomorrow. And yet, you know, you just hung in there. So we do have a few questions queued up. Let me throw this in here. I know you were all just like on that track and enjoying that ride as much as you could. So I'm sure the questions are going to start filling in here as I can see. So Harvey, you've got it started. Great job. Great information. And Scott, for the record, how many tours of that project did you give, including the one tonight? Because you can add this to the list.
Well, I'm sure we've done 6 or 7, but I've done a lot of private tours too. You know, I've had the architect who's doing our 60-story fancy one Monty's working on it downtown. We've had him through on a private tour. I've had Lloyd through on a private tour, Lloyd Alter. So quite a bit. I actually have keys to the building. So if anybody's in town after we get through COVID, you contact me, we might be able to go on a little walkthrough.
Well, yes, and also Jeff, who's somewhere on the call, he's also renting one of the units, so we can stop at his place for beers because I know he's got beers in his fridge.
Yeah, absolutely.
And we can get.
And that's actually an interesting. Thank you for calling it out, Sean. But there are several projects in the city of Vancouver, and including some of the major signature projects, where the developer was really uncertain about Passive House until Scott gave them a tour of this building, and they realized it's not that big a deal. So this building has had a fantastic leverage effect, and all of that time Scott's poured into showing it to people has had a big role in making Vancouver the Passive House leader it's become in the last couple of years.
And it's interesting how important the tour is, because as part of it took me about 14 months to convince the client to do this. But I had a client, 8th Avenue Developments, Ed Collick, who I knew I could talk to. And that's so important that you can get a conversation going. They wouldn't commit, but they were listening. And eventually we went down to Portland, Oregon. We all jumped on a plane. The contractor, myself, the envelope consultant, the 4 of us, we jumped on a plane. We flew down to Portland. We went to see the Orenco Passive House, which Walsh Construction was building down there. And they looked at those details and said, well, Scott, your details are easier than that. I'm not sure whether they are, but anyways, that's what their opinion was. And they said, well, if they can do that, we can do that. So that's really was key, was that tour to get them off the line. And once we got them off the line, we talked to the city of Vancouver. They were all over it. They actually came to our conference room with 4 people, and including the building manager of the civic facilities in Vancouver. And it really did kick off the revolution. And it's the most important building I'll ever do. I'm getting along in my career for sure. But it was a fun ride. It's still a fun ride. So anyways, thanks.
No, Scott, and again, your leadership in being accessible to give tours was phenomenal. And again, also with the great mock-up you guys built to just show all the trades and get them, you know, those are some good successes from that project. And thank you for sharing all the learning that you've done. And so let's dive into questions. Harvey, you had 3. Why don't you start off with one of them?
You know, I have to say that was one of the best presentations I've seen, and I'm so in awe, I can't even remember any of my questions. So if you could remind me, Sean, I'll go from there. But man, oh man, first of all, Gesa's like an auctioneer. She whipped through that so fast, it was unbelievable. I was ready to say, I'm buying that, sold. Great job. Sean, what was the main one? I can't remember. Seriously, there was so much information.
I'll pull out one. What will be the approach for IHG in the future?
Right. You had mentioned that your takeaways, and you didn't really you sort of just threw at it and then didn't go any further. So on your next building that you just put up at the end, because of the internal heat gains, what did you learn from this building, and how's your approach for the next building? Thanks, Sean.
Well, I'm going to admit that I put this presentation together very, very quickly about a year ago, most of this data. And it was when I went back to look at this data and really think about it, because we've been so busy building buildings, we haven't had time to really study data and think about it. We're architects, we don't normally deal in data. You know, we deal with, you know, pretty buildings and all that kind of stuff. And what Passive House forces you to think about is energy and how these buildings work. And so now that I've relooked at the data, we're going to be Lindsay's, by the way, Lindsay's on this call, and she's, I've hired her, we've trained her to do energy modeling. So that's her thing. And so Lindsay and I will be going back and thinking about, well, what happens if we make the internal heat gains higher in these buildings? What are we going to see the effect of it? And so I think we still have to do more of that in our buildings, but I know that there are some overheating and some climate data change facilities coming in the PHPP. I don't know if they're available for now, but I know they'll be in the new PHPP 10 when it comes out. And that's going to be very important to thinking about how we do these buildings and how we deal with this question of climate change. But certainly for me, we've got to put some cooling in, even in Vancouver. And as we get to these climates, you know, I think about the interior projects and the northern projects where we get, you know, the odd really hot summer day, and we get these mightily cold winters, you know, minus 30. We've got to really be thinking about. And the answer is, I'm very less concerned about the energy we use in the summer for cooling, because we're going to be able to put solar panels on our roofs, but there's lots of ways to generate that energy. But in the winter, there's not very many ways to generate energy. And you're relying on that grid, and the grid's going to be, you know, using, here in BC, we're lucky we have very green grid with most of it hydropower. But that's going to be key. You know, how do you balance these buildings to what's actually going on in the grid? And I think we need a little more study on that, about what's the best way.
Thanks so much. That was fabulous, fabulous presentation, fabulous project. Thank you.
And if you missed it, look up in the chat or save the chat, and so you can get the link that Zach put there, so you can get a copy of the presentation and all the slides. So thanks, Zach, for doing that, and again, thanks, Scott, and for putting out that your slides so we can dive in deeper afterwards. Lindsay Klein is next.
Thank you. I wanted to ask about the elevators. They sound like they might be very interesting for all of us.
Well, I guess Gesa can probably answer some of these, but I'll answer that question. We were looking for elevators, and we really don't have good data yet on how much energy these elevators work. But the key was we found one that had a very low horsepower motor, whereas the old hydraulic elevators would have 35 or 45 horsepower motors. These have 8.5 horsepower motors. So clearly they're more efficient. And what's interesting about them, because they have counterbalance on them, they actually probably use more energy going down than they do going up. And these do have regeneration on them. So what happens is they will regenerate a little bit of that electricity back into the system. In that last building, the Narrows building, we're putting together with actually with RDH, I signed the contract today, to put some monitoring together on that building so that we can actually measure the elevator energy. We're going to specifically measure elevator energy, because a lot of us that are modeling these things don't really know what we're actually should be using. We're all guessing a little bit using the elevator calculators on websites and things like that, but they are very efficient elevators, and you know, they shut down and they go into sleep mode, and how they're programmed is important too. And quite honestly, I don't actually know how that one was programmed. We talked to the programmers a little bit about it, but how we verify that, it's an interesting question. I've never, you know, I haven't done that, to tell you the truth.
Did you do a lot of research to find that particular elevator?
We did. We did a lot of research to figure out if that was a good elevator, I think is what I would say. It took quite a bit, and we had a lot of conversations with RDH and other people that were in the community. And at the end, we kind of concluded that was the best option locally available, and we picked it. And the price was reasonable. It wasn't a terribly expensive option for us.
Thank you.
Thanks, Lindsay. Melvin, you had a couple questions about indoor air quality and CO2.
Yes, can you hear me?
Yeah.
Yeah, and I'd like to say I'm one of those people that did take almost every public tour of this building, and yeah, it was great. Yeah. So yeah, the question was, where are the CO2 monitors placed? And as a follow-up, is the CO2 data before or during COVID? And the reason why I asked this is working at home and having one of these in front of me now, I noticed that acoustics is a big issue and smoke is a big issue. So when I close my bedroom door, I noticed that my CO2 jumps from like 400 or 600 up to like above 1,000 ppm.
So my first question for you, Melvin, do you have an HRV in your room that you close the door on?
No, I don't.
One of the things that I think is important, and we kind of deal with this, our building code says that we're supposed to ventilate every room. In these small apartments, I like to cheat to put it into the bedroom, because the bedroom is going to close the door. And the air that's going out, getting into the bedroom, is ultimately going to come out underneath the door and end up in the living space. So I think we should cheat our ventilation a little bit to the bedrooms. And I think that helps. Now, those monitors are generally in the suite. However, I've talked to Jeff who lives in the building, and I told him I want to put an aware in his unit, and he's agreed to it. So we're going to probably do that sometime in the new year, and I'll let him move it around the unit a little bit, and maybe we'll find out what goes on in the bathroom and what goes on in the kitchen and what goes on in the living room. So I've got a guinea pig in the building now, so that'll be kind of fun. And we're actually using Jeff's company to design a couple of other passive houses that we're working on right now.
Yeah, Jeff's good to be at a guinea pig for a whole bunch of things.
Happy
Young, talented, hardworking kid.
He's going to feed us all beer down in the common room.
Yeah, and just remember, he'll drink twice as much as any of you, so bring lots, because yeah.
I got a stock beer fridge at home here.
Thanks, Jeff. Appreciate that.
Yeah.
Melvin, thanks for that question. Very excited to bring on Witta, who didn't really have a question, but I just want to give her praise because I don't know what time it is in Germany, but the fact that she's been staying up late the last few weeks to join in on our events, bravo, thank you for joining us. And she put a comment about,
I have to get you a
I forgot what it was.
monitor for your bedroom.
Oh, sorry, Lindsay, what was that?
Sorry.
Did Witta have something to say?
I thought she said she wanted to put a monitor in Sean's bedroom, but maybe I misheard.
Yeah, sorry, I really apologize. It's our daughter.
That's an after hours conversation. We're still in the PG version. Hold on, we'll get there. Witta, are you there? And would you like to comment about indoor air quality? Sorry, Witta? Oh, maybe I just had her queued up, but maybe I lost her.
I see Stuart Hood is on the call, and Stuart Hood's from Integral Engineering.
Hello.
Stuart.
Do you hear me?
Sorry.
Hi, do you hear me?
Yes.
Hi, Witta.
Hello. Hello.
We can hear you.
Yeah.
Thank you.
I wanted to say something to the climate data. Of course, we always have climate data from the past. So that's very natural because these are collected climate data. But it's changing faster. So we also we adjust it regularly in the PHPP and we'll also adjust it further. Since this process is faster and faster, we recommend that you really make a stress test, especially when you're calculating overheating. This is really very sensible. And of course, you're dependent on the use of buildings. So you need to close the shutters and you need to do the ventilation as it assumed. And of course, when it even becomes warmer, then it can still be hotter. So, well, you can only get out of the PHPP when the input is the same as you have in the PHPP. That's very natural. But this is much more sensible. So we always recommend to do a stress test with climate data, which are hired. Look what happens when the users don't ventilate as assumed. What happens when they use the shutters another way. So that's what we recommend. And in the next PHP, we also will build it in as a normal function in PHP 10. So that's what we will do. We know about that. And the other thing is use active cooling when there's a big risk.
I think, Witta, thank you very much. I think this was our very first passive house. I was so happy just to get it built and just to get it over the line. And it was an important building, and it's really influenced what we're doing now. And
yes, it's great what you have done, and everybody needs his own experiences. I just wanted to comment in general. It's a fantastic; these are fantastic projects, and thank you so much for sharing what you have done. So many details, and also the monitoring data and the experience you have. So this was only a general remark, and of course we know the problem, and we will make it more clearer and easier for future buildings.
So a fun story while I've got you on the line, that when I went to the very first International Passive House conference, it was in Leipzig. And I really was concerned about ventilation. So I had to go to all the ventilation workshops, and they always kept saying that we had to have individual control of ventilation for each suite. And I had been thinking about this semi-central ventilation system as a way to push my client over the line to say, hey, I can put one of these units in for 5. And I kind of came out of that a little bit down, and then I got introduced to Wolfgang. And I'd never met Wolfgang. It was my first meeting. And afterwards I said to him, after I met him, I said, this is our strategy. And he said, oh, sounds good, no problem. And I thought, hey, I got it from the horse's mouth. We have a solution. And so it kept us going. So it was very, very nice to do. So tell him thank you when you talk to him.
Thank you so much. And of course, also, we were not always aware that climate change now is so fast.
Yes, yes. And we're all learning. And that's, and
we're all learning.
And that's what's important.
We also learned from you. So thank you so much for all what you're doing and what you're sharing.
Thank you, Vida.
Hey, and just to summarize a little bit of that learning for a second, we have been fantastically fortunate to learn from this building and some of the other early Cornerstone buildings. BC Housing has funded some ongoing study. University of British Columbia is looking at climate sensitivity studies that we're going to be working on over the coming months to try to refine our modeling. And what we're seeing is that there's actually several factors all happening at once. The local heat island effect for buildings like this is real. The temperature at the site of this building in the city of Vancouver on our arterial road is almost certainly a degree warmer than the climate file now. We have already warmed between 0.7 and 0.9 degrees warmer than the weather file or the climate file we're using. And so we have about 1.5 degrees kind of baked in. And as you saw from Scott's slides, there's a heck of a lot more electricity being used and a heck of a lot more hot water being used than are in the assumption. When you add the internal heat gains, plus the local heat island effect, which we're not really looking at seriously, plus the climate effects, plus the fact that it's on a busy arterial street, and a lot of residents might choose to close their windows for noise or smell reasons, and therefore lower the amount of natural cooling. You kind of have all these things coming together, and it's really hard to say in any given suite, this was the sole factor, but they aggregate quickly. And we're building those into the way the City of Vancouver and BC Housing is requiring summer comfort models for future buildings. And so there's already been a lot of learning for this, and we're tremendously grateful for these lessons.
Hey, Scott, I think you were going to ask me a question before, but I'll just weigh in anyway. We were mechanical engineers on this project, so it's nothing like having the project that overheats on your resume, is there, right? But there's no cooling in it, so you get a little bit of forgiveness. But I think one of the things that I would say that we did learn, and Scott, the shading coefficient on the glass in this building is in around the 0.7s. I mean, today in most commercial buildings, we don't do anything less than 0.3, and the chasing of the low teddy to hit the PER was, I think, responsible for some degree of this overheating, right? If you have a teddy of 6 instead of 15, then clearly you've got it over insulated and too much heat coming in. And so, getting well below the 15 number in my mind is not something we should be trying to do, right? We should be hitting the 15 number and not going drastically below it, because the consequences on the other side, you're going to see the negative effect in summer. So I think that shading coefficient and more aggressive, overhangs, I think that was talked about in the presentation. Some of the solar shading could have been denser, perhaps, right? So I think there's a number of factors there. While we say it's all about internal heat gains, it is about internal heat gains partially, but I think that the solar aspect of it, keeping that solar gain out is a much bigger factor. We have passive houses that we've built in Vancouver that are not overheating. They have cooling, but they're not using the cooling because they've been more aggressive with the glass and more the shading coefficient, and more aggressive with the overhangs. So I think there's a lot to be learned there. You only have to move the shading coefficient by 0.1 or 0.2 to make massive differences when you've got quite a lot of glass.
Yeah, I think that was the biggest lesson for us, Stuart. And of course, what's happened is the PER calculator has changed now, and we're able to, in a dense building where we have these dense suites, we're not, well, in this building we were doing it under PE, which was 120, and we came in at 117. But now it'd be 140, 150 or something we could have gone for, and that would have made a huge difference. And we would have then probably certainly we would have put way lower solar heating class. I think that was the biggest mistake we made on the building of all the pieces. And I think, again, the shading could have been a little bit denser. We had, the shading changed a little bit for cost savings and maybe wasn't as well optimized as it could have been. So, yeah. But again, those are lessons we learned.
Absolutely. And I think the other one to just touch base on, Scott, is the electric baseboards. The electric baseboard heaters do push up that direct electric heat. Does push up the PER, right? Because it directly translates, and it's a 1-for-1 ratio, and then by the time you put the factor in there, it scales it up a lot. So if you have a heat pump in there, and I think this is the way we're going with most multifamily now, we're putting a heat pump, coil in the ventilation air, which is the one that Scott showed on the narrows, and so that heat pump, while it cools the ventilation air, provides a little bit of tempering of the ventilation air, but also provides efficient heating. It doesn't provide all of the heating, but parts of the heating. You still have that electric baseboard heater, but the electric baseboard heater is just doing top up as opposed to doing the base load of the heat. So I think that feature, can really work in your favor. But there's of course some cost with that heat pump. But at the end of the day, it works at both ends. It works on both the heating energy and on the reducing or eliminating overheating.
Well, we got one we're working on now with you, so we're going to put all those lessons in there over on Spire Landing too.
Yeah, absolutely.
Exciting stuff, everybody. Zach, let's just wrap up the happy hour, and then we can dive back into the questions.
All right, sounds great. I just want to take a moment to thank the people who made tonight possible and who make all of the work of Passive House Accelerator possible. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Mitsubishi Electric HVAC US, RDH Building Science, StoCorp, and Zola Windows. Thank you to our stakeholder partner, NYSERDA, and also thank you to our patron sponsors, Innotech Windows and Doors, Morrison Hirschfield, and Partel. Next week, we have some cool stuff coming on. The first one is actually a virtual event that everyone here is welcome to, and that's Passive House Northwest's Solstice Holiday Happy Hour, Monday, December 21st. I'll post details or a Zoom link in the chat soon. But it's a great group of folks. I know many of them. I'm based in Seattle, so it should be a fun social gathering. On Tuesday, December 22nd, we have Ian Robertson of A.A. Robbins Architect, and he is going to be talking about the 6 flavors of timber. And some of you may want to spell that with PH instead of the F. Ian put into this project 6 different types of timber, of manufactured timber, so manufactured woods. So really cool projects, CLT, NLT, and all of the above. So check us out on Tuesday of next week. And then Wednesday, we are having a party and a kind of information gathering event from all of you. So 2020 wrapped, thank goodness, and 2020 envisioned. So we're looking for your feedback on what you'd like to see from the Passive House Accelerator in the coming year, and we'll be doing some some activities to gather some info from all of you. And I think that's it.